Number properties are certain rules that can be applied when performing arithmetic operations on numbers. In this video, we're going to cover 4 topics under number properties. There are precedence of operators, basic number properties, identities, and inverses. Let's begin with the precedence of operators, also known as the order of operations. In mathematics and programming, the order of operations, or operator precedence, is a collection of rules that reflect conventions about which procedures to perform first in order to evaluate a given mathematical expression. Now remember, a mathematical expression can be in the form of numerical expression or algebraic expression. So by convention, formulas or expressions are evaluated in the following sequence. So we deal with the parentheses first. Parentheses involves all kinds of brackets, such as round brackets, square brackets, or curly brackets. And then we deal with the exponentiation or radicals, or we call that the powers. And then we deal with multiplication and division, and then addition and subtraction. In the case of operations of the same level of precedence, such as multiplication and division, or addition and subtraction, the evaluation proceeds from left to right. Now, let's take a look at some examples. In this example, you are asked to evaluate a numerical expression. Evaluate here means that you need to calculate what is the resulting value and simplify all the terms in this expression. Pause the video and try to work this out and see if you can get 55 as the answer. I'll present the answers to you shortly. In this expression, if we follow the precedence of operators, we'll need to deal with the parentheses first, which means that we'll need to simplify what is 5 minus 2. So that gives us 3. After this, the next step is to deal with the exponents, which means that the term with the exponent is 3 squared. So simplifying 3 squared gives us 9. Hence, this gives us 100 minus 9 times 5. The next step in the precedence of operators is to deal with either division or multiplication. So in this case, we will have to simplify 9 times 5. So that gives us 100 minus 45, and hence the answer is 55. So I hope you got that before we move on to example number 2. In example number 2, you are asked to simplify an algebraic expression. In this expression, there are different levels separating the numbers from the algebraic terms. There are also brackets here, and there are 2 levels of brackets. So according to the precedence of operators, we will need to take care of the brackets first. So since there are 2 levels of brackets, we will deal with the one inside of it. So first step is to simplify the exponentiated term inside the bracket, which is x minus 2 squared. So x minus 2 squared is an algebraic term that requires expansion. So expanding x minus 2 squared will give us x squared minus 4x plus 4. Okay, this is equivalent to x minus 2 squared. After this, we will need to simplify the terms inside the bracket with -1. So we are still dealing with the parentheses first. And after combining x squared minus 4x plus 4 minus 1, so that gives us x squared minus 4x plus 3. Next, we'll deal with the square brackets here by multiplying each term in the bracket with -5. So simplifying that would give us -5x squared plus 20x minus 15. In this step, you should be aware of the negative sign in front of the number 5 when doing your expansion. The last step is to, of course, collect the like terms. Collecting like terms would mean that you are combining all the terms with the same either exponent or terms. Like, for example, 5x squared is on its own, and 2x with 20x, and then the number with the other number. So it would give us 22x from 2x plus 20x, and then we have -5x squared, and then we combine -15 with plus 2 to give us -13. And in mathematical convention, we'll always arrange the terms from the highest exponent to the lowest exponent. Hence, the answer is -5x squared plus 22x minus 13. A few more examples for you to try. Use the order of operations or precedence of operators and try to work this out. We'll discuss in class later. Next up, we have the basic number properties. These are the laws that govern numbers and algebra. The three basic properties of the number system include commutative law, associative law, and the distributive law. Firstly, we have the commutative law. The sum or product of terms is unaltered by reordering its terms or factors. So commutative law, as you can see here, changing the order of the terms does not change the result. For example, if we change the order of the first equation, a plus b, the first expression a plus b, and write it as b plus a, these two terms or these two expressions are equivalent. It does not change the result regardless of what the value of a or b is. Similarly, a times b is equivalent to b times a regardless of the values of a and b. So this law is valid for addition and multiplication, which means that this equation is true for any terms that is that is added or multiplied, and it is not valid for subtraction or division. So try it yourself and see whether or not the laws or this commutative law is applicable for subtraction and division, which means that if we have a minus b, is it going to be equivalent to b minus a? And similarly, when we have a divided by b, is this going to be equivalent to b divided by a? Look at the associative law. In the associative law, the terms or factors may be associated in any way desired, which means that when we change the grouping or the brackets, it does not change the result. In this still equation here, you can see that the expression on the left is equivalent to the expression on the right, regardless of the values of a, b, or c. So this is valid for addition and multiplication, so as the two examples here, and it is not applicable or not valid for subtraction and division. Can you prove it? Try it out. And the third law is the distributive law. In the distributive law, applying the outside term to all the terms on the inside of the brackets should give you the expanded term where the expression on the left is equivalent to the expression on the right. So for example, if we multiply b plus c each term by a, so we'll get ab plus ac. So this equation is true regardless of the values of a, b, and c. Similarly, when we have a times b minus c in the bracket, this should be equals to ab minus ac. So this distributive law is applicable or valid for addition and subtraction, and it is not valid for multiplication and division. So try it out and try to prove that it is not valid for multiplication and division. Let's apply number properties, or as the three properties that we've mentioned earlier, in simplifying this algebraic expression. So we have 3a minus 5b plus 7a. So that is the given statement. Applying the commutative property, we can change the position of the two terms on the right to get 3a plus 7a minus 5b. So basically, we are just rearranging the terms, and this one is still equivalent to the given terms. So 3a plus 7a, these two terms are called like terms, and they can be combined using the associative property. And then 3a plus 7a is equivalent to a times 3 plus 7 because a is the common factor in each term. And simplifying 3 plus 7, so that gives us 10a minus 5b. And this is again by commutative property. Try simplifying these expressions and try justifying each step of your way as we have seen in the previous slide. Apply the number properties when you do so that you're aware of which property is applied when we are trying to justify our steps. Next up, we have the identities of operation or the identity property. An operation works to change numbers. Basically, there are 6 operations in arithmetic that work on numbers. So we are well aware of addition, subtraction, multiplication, and division. So these are called binary operations. So binary operations requires 2 numbers. So as you're familiar, addition, subtraction, multiplication, and division requires 2 numbers at least in order for the operation to work. We also have operations such as raising to a power, or exponentiation, or taking roots, which does not require 2 numbers. So an identity element or neutral element is a special type of element with a set of respect to a binary operation on that set, which leaves other elements unchanged when combining with them. When you use an operation to combine an identity with another number, that number stays the same. Let's look at some examples here. First up, we have the additive identity. An additive identity is a number that when added to any number gives the sum as the number itself. For example, if we have the number a, then if we add a, we add 0 to a, that is equivalent to a because 0 preserves identity under addition, which also means that any number, when we add 0 to that number, we get the number itself. That's why 0 is the additive identity. So for example, 2 plus 0 is still equals to 2. Any number plus 0 is the number itself. Next up, we have the multiplicative identity. Any number multiplied by 1 remains constant. The multiplicative identity is 1. So a, being any number, multiplied by 1 is equals to the number itself. Like for example, 100 times 1 is still equals to 100. Therefore, 1 is the multiplicative identity. So the basic identity of addition is 0, and the basic identity for multiplication is 1. So here's a question for you. What are the identities for subtraction and division? Lastly, let's look at the concept of inverses, or the inverse of an operation. The definition of inverse is this. The inverse of an operation undoes the operation. So inverting an operation gives its identity. For example, when we have addition, to inverse or to undo addition, we apply subtraction. Therefore, subtraction is the inverse of addition. So if we have the number a, so a plus minus a, we have 0, 0 being the additive identity. Can you guess the inverse for multiplication? That's right. If you have any number multiplied by the inverse of that number, which is the division of that number, or 1 divided by a, we'll get the number 1. 1 being the multiplicative identity. Therefore, the inverse of multiplication is division and vice versa.